No. Ah, molt bé. Ara ho veig. Merci. Molt bé. Bé, si us sembla, comencem la sessió. Comencem la sessió. Benvingudes, benvinguts tots els assistents, les assistents a l'Institut d'Estudis Catalans, on tenim el goig que se celebri la creació de la unitat ELLIS Barcelona. Realment per nosaltres no només és un plaer, sinó que és una gran oportunitat que us reuniu aquí perquè teniu l'oportunitat de conèixer exactament en quin edifici, en quin organisme us trobeu. L'Institut d'Estudis Catalans, com sabeu, és un organisme acadèmic nacional, de caràcter nacional català, que va ser creat políticament, per tant és l'únic organisme acadèmic creat políticament, a començaments de segle, quan volia identificar-se la comunitat catalanoparlant i sobretot en aquell moment la comunitat catalanoparlant de Catalunya volia identificar-se com un poble o, com aleshores deien, com una nació. Aquesta és la raó per la qual un dels nostres objectius és fixar la norma de la llengua catalana, no només fixar-la la norma per Catalunya, sinó per tots els territoris catalanoparlants. Per tant, també en contacte i de bon acord amb l'Acadèmia Valenciana de la Llengua, que va ser de creació política valenciana, anem treballant o treballem per una sola norma per la llengua, per fomentar que realment hi hagi unitat. Però ens ocupem, o se'ns va donar el mandat, d'ocupar-nos també de la qüestió de la recerca i de la qüestió de la difusió del coneixement i de suport a la innovació, que això ens ho hem afegit nosaltres amb paraules modernes. Deixo de banda la qüestió de la recerca perquè l'Institut d'Estudis Catalans no té cap interès de competir amb els centres de recerca ni amb les universitats. La recerca de punta, la recerca internacionalitzada es fa en els centres de recerca, però en canvi sí que l'Institut té l'obligació d'ocupar-se de temes de recerca, moltes vegades molt descriptius o de recopilació de materials que realment afavoreixin, donin peu o facilitin altres recerques, hipòtesis, etc., sobre tot allò que fa referència a la nostra història, a la nostra geografia, al nostre patrimoni cultural o al nostre patrimoni natural. I, lògicament, també a la nostra tecnologia, perquè la tecnologia forma part de la cultura. Forma part de la cultura. Per tant, per nosaltres és un goig que se celebri avui la creació de la xarxa ELLIS, perdó, de la unitat ELLIS Barcelona, perquè és la unitat ELLIS Barcelona, al costat de les dues que ja existeixen a l'estat espanyol, a Madrid i a Alacant. Dono les gràcies molt especialment a la Carme Torres i al Dimos. La Carme Torres és membre de l'Institut d'Estudis Catalans de la secció de Ciència i Tecnologia i vull saludar molt especialment la presència de la Mireia Arnal del Departament d'Universitats i Recerca i a la Gina Tost del Departament de Transferència, secretària de Polítiques Digitals de la Generalitat de Catalunya, que venen en representació dels consellers respectius. Si us sembla, doncs, benvinguts novament. Us he donat la benvinguda en català. Jo soc de les que defenso que en la seu de l'Institut d'Estudis Catalans s'ha de garantir el dret del catalanoparlant, expert, especialista, a dirigir-se a un auditori tan internacional com vulgueu en la llengua pròpia, perquè som l'Institut d'Estudis Catalans, sempre i quan tinguem el suport, com li deia la Gina Tost, d'un interpretador que passi del català a la llengua internacional, que pot ser l'anglès. Moltes gràcies, doncs, per la vostra assistència, molt benvinguts tots, i passo la paraula a Carme Torres, que us pronunciarà la seva locució a continuació. Endavant, Carme.
Bon dia a tothom. Doncs deia bon dia. Mentre no tinguem la interpretació, jo parlaré en anglès. Good morning, everyone. Believe me, I am very, very pleased to welcome you today in this inauguration event. We have been longing for this kickoff to happen since long ago. And finally, thanks to the collaboration and good efforts of the Catalan government, present and past ministers, directors and secretaries of different departments, universities and research centers, and many of you individually, I see Professor Mas-Collell here, we are finally here. It is nice that this inaugural event is taking place in this beautiful venue, the Institut d'Estudis Catalans, and we thank very much Dr. Teresa Cabré for hosting us today here. As she said, the Institute of Studies Catalans is the academy to enforce Catalan culture and carry out Catalan studies in all science and the humanities. It is also a pleasure and an honor to co-chair, together with Professor Dimosthenis Karatzas, this outstanding group of researchers that conform the ELLIS unit Barcelona, and many of whom are here today. In these turbulent times in which AI is always in the news, for the best and worst reasons, it is of utmost importance that researchers in public and private sectors, institutions and administrations join efforts to guide the deployment of this powerful technology to solve the important problems humanity is facing, and not creating new ones. In this regard, debates within the AI community foresee 5 possible future scenarios. One is regression, namely AI enters a new winter, as it already happened before. Second, positive progression. The AI revolution is integrated as one more revolution in society, as the agricultural and industrial revolutions have in the past. Third, negative evolution. AI progressively takes on human capacities, which is sometimes already happening, and humanity goes on the decline. Fourth, the singularity, everyone has heard about it, occurs as predicted by some. AI outperforms human intelligence and humanity becomes an extinct species. And 5, the singularity leads to a post-human society hybridizing machines and humans. Well, of course, these are not clear-cut futures. Some of them may coexist and other possibilities may arise. Debate on future scenarios has already helped the community to focus on research topics like, for instance, trustworthy and responsible AI or human-centric AI. Such debate on future scenarios has also pervaded to society at large, leading to ethically regulate AI by issuing guidelines and norms such as the AI Act that was released last December by the European Union. We are currently at a crossroads, and depending on how AI develops, we can focus towards the next scenario or another or a combination. And we have a responsibility. The ELLIS network offers a privileged ecosystem to develop machine learning in an ethics-driven, beneficial way for humanity. The Barcelona unit is committed to carry out research, guide innovation, and influence policy-making towards the most favorable scenario for citizens and for society as a whole. This is, I think, what has gathered here us today. Thanks all for being here. Thank you.
Té la paraula ara la senyora Laia Arnal, directora general de Transferència i Societat del Coneixement de la Generalitat de Catalunya.
Bon dia. Good morning. Welcome, everyone. Today, I represent the Ministry of Research and Universities. And first of all, I would like to excuse the Ministry, Senyor Joaquim Nadal, who couldn't attend this meeting. I'm really proud. Fa molt de goig aquesta sala, and I think it's a sold out. It's really amazing, the quantity and quality of people that are joining today. I would like to start giving thanks to l'Institut d'Estudis Catalans per allotjar aquesta iniciativa, perquè efectivament ciència, innovació és cultura. Per tant, gràcies per allotjar-nos i acollir iniciatives transcendents com aquesta. I would like to congratulate especially the organizers, the promoters of this strategic initiative, especially the ones that believe it from the beginning. I would like to congratulate them for the program of today, right, and for the assistance, and also not only for the creation of this unit, but for the fast speed in which it has been growing through the last few months, actually, so congratulations. I would like to briefly explain you about a few notes about the excellence of the research and innovation, the Catalan system of research and innovation. It is well known that we are recognized as a competitive science and knowledge hub, not only in Europe, but around the world. Why? We do have a dozen of universities. Some of them are carrying out very good activities in training digital and creating digital talent. We do have more than 60 research centers, both from the regional government, from Catalonia, but also from the state. We do have very competitive infrastructures, facilities, Barcelona Supercomputing Center, the National Center for Genomics, the Synchrotron ALBA. We do have technological centers, we do have lots of facilities. This means that we do have 50,000 people working on research and development jobs, right? This means that we do have about 1,700 research groups, of whom about 70 are working directly on AI. This represents that Catalonia has almost 1.5 global population of Europe, and this represents and actually means 4.5 of the whole scientific production in terms of papers and publications. This is relevant percentage. So we do carry out basic research, applied research, translational clinical research. We do develop new technologies, not only in the area of technology, deep technology, life sciences, but also social sciences, humanities, and other areas of knowledge. And in terms of quality, this is also a renowned hub of knowledge in terms of some dates. In the first half of the Horizon Europe, Catalonia has attracted more than 1,500 million euros from the program Horizon Europe. This means that you are developing 1,300 new projects, right? In several areas for sure, but that's a relevant percentage. This means that we are the third region in terms of attracting funds from the Horizon Europe, after Paris, after Munich, and we do have, in average, the same size as countries, as Finland, or as Denmark, in terms of attracting European funds. Regarding the excellence funds in the European Research Council, Catalonia has raised 145 new projects, which represent about 200 million during this first period of the current Horizon Europe. So this is relevant. It means 3.5% of the whole ERCs during the last period. Regarding innovation, following the Regional Innovation Scoreboard, Catalonia is a strong innovator, still minus, right? So we do have to continue working hard, but there we are, so it's relevant. Talking about innovation, what about spin-offs? So the last few years, Catalonia has created about 300 spin-offs coming from the academic and research centers, so that's relevant. But beyond that, Catalonia, it's becoming, and it's being recognized as a region of startups. So we've been on the top positions in ranking in Europe as the second, the third, the fifth best city to create new startup-based, technology-based companies. Beyond this, what about big companies? During the last years, Catalonia and Barcelona are attracting large corporations, global corporations like AstraZeneca, like Oracle, like Microsoft, like Amazon, like others, right, which have a strong component in digital, in AI, and they are, landing some and creating some decision in terms of research and innovation sites here in Barcelona. Why? This is not a coincidence. This is because Catalonia has knowledge, has talent, has infrastructures, has a political administrative framework, which is on the way of doing this, has companies, has industry, and a key point, relations, because it's not only to have these several elements, as a system, but we have to be competitive and act as a whole, right? So relations is a key point. When we say relations, we mean alliances, and we mean nodes like this one, right? So relations, let's talk about the power of the nets, right? Catalonia and Barcelona during the last few years have hosted and created and attracted some relevant of global reputation initiatives. Fusion for Energy, the EMBL chapter, some flagships, right? And the EIT, the EGA initiative, and others, Fraunhofer soon, right? So it's relevant to create these sites, these units, these nodes. It's a key factor, indeed, to have this excellent ecosystem. I would like to point out the support and recognition from the regional government, from the Generalitat de Catalunya, especially from the Departament de Recerca i Universitats, with this initiative from the very beginning, giving the absolute commitment and support, and in the future, absolute total confidence, right? And high expectations also, high expectations as an instrument to carry out and develop the AI strategy of the government, as expectations in terms of creating talent and creating new jobs in the future, and to be of influence, to be relevant in the design of new research policies and public policies. So finally, 3 recommendations I would like to say you. First, collaboration in capital letters. Share goals, share best practices, keep on going, be generous and transparent, and identify the best partners and go ahead and attract them, right? Public, private, industry, social agents, all of them. Ambitious, be ambitious. I mean, complex challenges need complex solutions, right? So identify the best and go ahead, right? And we are here to change paradigms, and we are here to change the rules and to write and to design new rules. And finally, impact. I mean, it's a matter of, it's not only value creation, this sounds me like a few years ago, but yes, we do have to create with this knowledge economical, social, environmental, cultural, new value, right? So it's relevant in terms of business, in terms of improving innovation, in terms of improving entrepreneurship and job creation. Be imaginative. I think you guys are designing new professions of high added value, like not a babysitter, but an avatar sitter, maybe, or a digital twin tuner, or I don't know, many strange things, like, but it seems to me like 10 years ago, when social media, crashed, we didn't know what about the influencers, and we didn't, so you are designing new jobs, right? And 2 more messages, please. Inspiration, you may be an inspiration for a new generation of leaders, thinkers, and innovators. And finally, a hope for citizens. We need you and we trust you. Thank you very much.
Ara a continuació té la paraula la senyora Gina Tost. Endavant.
Moltes gràcies, Teresa. La veritat és que crec que les energies de l'univers em castigaran per estar en aquesta casa i fer el discurs en anglès. No. Però bé, colaré coses en català, segur. Abans de res, excusar el molt honorable conseller Roger Torrent, que està de viatge a la Xina i no ha pogut ser aquí, però li hagués encantat presentar la ELLIS Barcelona, perquè sap que va de persones que treballen, no? I que s'ho han treballat absolutament. Let's switch to English. I would like to talk in terms of industry and in terms of future for the Catalonia AI, because the promotion of the artificial intelligence in Catalonia is a priority for us. We have been working to establish an international reference hub for research, for innovation, for talent generation, but also attraction, for companies, and also for investors, basically on deep tech, but mostly now based on AI, because now it's the trendy word. Now, if your microwave do not include AI, it means that your microwave is legacy. According to the latest study on AI in Catalonia, maybe you think that we have a couple of companies working on this, but there are 488 companies in the countries fully dedicated to AI, almost 3 times the number existed in 2019, the year when the previous study was conducted. And this generated a business value of 2,155 billion euros in Catalonia, 60% more than 2019. And as my fellow General Director Liu Junca might know, that Barcelona is leading the city in funding rounds for startups in the southern Europe, because we have a lot of an ecosystem that is bursting, that it's generating new ways of thinking, new ways of economy. And to this end, from the Secretariat of Digital Policies, we coordinate the Catalonia AI, which is the AI strategy for Catalonia. That includes a branch for ethics, the Observatory in AI in Catalonia, l'Observatori d'Ètica en Intel·ligència Artificial de Catalunya, l'OIAC, led by the University of Girona. Also, the Center of Innovation and Data Tech and Artificial Intelligence, el CIDAI, which promotes the innovation and the adoption on AI for different companies, led by Eurecat. And the community of companies developing or integrating AI solutions within the Digital Catalonia Alliance, led by I2CAT Foundations, or I2CAT. And finally, the AI Research Alliance, AIRA, led by the CVC, the Computer Vision Center, where we have the Heredai AI Network, La Xarxa Heredia, and this ELLIS unit Barcelona that kicks off today, and we are here to celebrate. This ELLIS unit will help consolidate the strong and fragmented ecosystem of AI in Catalonia that connects to the pan-European efforts of ELLIS. And a bonus track, I want to talk about 3 projects that we have here in Catalonia based on AI that I think that might be very interesting for you. The first of all is AI Accelerator, an initiative with the Computer Vision Center and I2CAT Foundation that aims to attract the best scientific and technical talent in AI from Catalonia and offer them the opportunity to work on technology, develop in research centers and universities, and bringing it to market and creating new high-value added companies. The second of all, because I'm seeing here BCC, AINA project, you may have heard about it, right, Teresa? To include Catalan, but not only the language, but also the culture into technology that we are using today and tomorrow, that maybe next year I cannot do that in English, maybe I will do it in Catalan, and I had a translator. But also to avoid bias. We have, as Catalans, we have the right to interact with technology with our own language. Right now, we don't have excuse. It's only an operation and budget part of any company. And also within the AINA project, there's the AINA Alliance that wants to include other languages and cultures from worldwide, because this that might happen to Catalan, might happen to every language and culture in the world. It's not the same to talk English from the UK than from Australia, than from other regions. So this unifying technology language might have happened if we don't do anything about it. And third, DITA, the Disruptive and Emerging Technology Alliance. This is a Catalan initiative that brings together dozens of governments worldwide representing some of the world's major technological hubs. It is open to anyone and any government from region and states around the world that show a clear commitment on democratic values, human rights, cultural and linguistic diversity, but also focus on technology. But people and their rights comes first. For these achievements that we are celebrating here today, but even more what we'll celebrate tomorrow, I'm sure, based on the talent that it's training for the future and learning, the establishment of the ELLIS unit in Barcelona heralds a new era of prosperity and firmly places us on the global map of innovation and excellence. Congratulations.
Bé, doncs, com hem pogut sentir, ens movem en un escenari en què hi ha innovació, gosadia i coratge, ambició, ètica, també, i tot això en col·laboració, sense exclusions, per aconseguir, finalment, que per tota la societat, per tota la humanitat, tinguem unes eines que realment puguin fer aquelles tasques que mai hauríem pensat que puguin fer. I ara que ja som, i jo me n'he assabentat pels papers d'aquesta reunió, a la segona fase de la intel·ligència artificial, perquè no sabia què volia dir la sigla intel·ligència artificial general, aquest general específic, i la Carme m'ho ha aclarit, doncs benvinguda sigui la unitat ELLIS Barcelona en aquesta segona fase. Moltes gràcies i us desitjo que tingueu una bona jornada i que gaudiu realment de les ponències que estan preparades. Molt bé, hem continuat el nostre mandat.
Continuing with the program, the next speaker will be Dr. Niccolò Cesabianchi, who will present the ELLIS network. I don't know if we have spelled out ELLIS yet. So it means European Laboratory for Learning and Intelligent Systems. Dr. Cesabianchi is a member of the ELLIS Governing Board, co-director of the ELLIS Unit Milan, and member of the advisory board of ELLIS Unit Barcelona. So the floor is yours. Thank you.
Thank you much. Okay, can you hear me? No? Okay, good. Thanks a lot, Carmen, for the introduction. I am Niccolò Cesabianchi, and yes, I'm a co-director of the ELLIS Unit Milan, and which is made of several institutions. So I know what it takes to create an ELLIS unit, coordinating different entities. It's a lot of work. So congratulations to for succeeding, and this is really great. And for me, it's both a pleasure and an honor to be a part of this celebration, and this recognition of thanks of the excellence of the science in Catalonia and in Barcelona. And this is especially true because also of my history. I've been collaborating with scientists in Barcelona for over 25 years. And I've done some of my best work in collaboration with people in Barcelona at the different universities. And I'm really in debt for that, for this, for this. And I can fairly say that if I am, if I am a scientist I've reached a certain point in science, it is also because I've been collaborating with some very excellent people here. So, and this is true, this has been true long before ELLIS existed. So I'm really in admiration of the degree of excellence that Catalonia and Barcelona has been able to express. So let me say a few words about ELLIS. And okay, yes. All right. So ELLIS, the general idea is to overcome certain fragmentation that exists in artificial intelligence science and development in Europe by coordinating the different excellence centers at the European level in a network. And this means essentially three things. So creating a coordination at European level, but also being able to attract talents from outside of Europe and keep the talents that we have in Europe from going away to other places. And second, we would like to be able to strengthen the local ecosystem. So to act not only at the European level, but also locally, to have a benefit on the interaction between the universities and the local companies. And therefore, this coordinated effort is something that only can emerge from a joint coordination. And this is the reason why ELLIS was born, and this is a picture that witnesses the creation of the organization back in 2010. So ELLIS is a European organization, but it was actually constituted as an association in Canada in December 2018. This was at the was already when the deep learning revolution of artificial intelligence took place. But so it was a good timing because we European scientists working in artificial intelligence and machine learning were already recognizing that something was happening in the landscape of artificial intelligence, and we had to join forces and do something to be able to stand up against do something for European science that could keep Europe at a level of excellence in artificial intelligence. So let me go back to the ELLIS mission. So as I said before, ELLIS is a pan-European network, and it is committed to development of ethical and trustworthy AI, based a lot on what are the foundational principles of the European Union, so human rights and respect for individuals. And again, the idea is to award excellence, to attract talents, and to have a positive benefit on the local economies. So so what is the structure of ELLIS? There's a governing board, which I am part of, and these are you see now the members of the current governing board, and there will be elections this year, so we will renew the board. And the president of the board is Bernard Scholkopf, and the vice president is Nuria Oliver from Alicante. And the board is helped by an executive committee that is managing the execution of the strategies that are devised by the board. Right, so how are we going to deploy the strategy for ELLIS? This is articulated in essentially 3 pillars. We have the ELLIS sites. So these are local entities that correspond to excellent centers in artificial intelligence research. And the ELLIS network is exactly a network of these local units where the best science is being carried out in Europe. Then there are the programs, and this is an orthogonal level. So this is programs are created around important research threads in artificial intelligence, and they connect different units that share common research interest. So they are gluing together work done in different units, and so this is going against the fragmentation that I was mentioning at the beginning. There's a third line, which is the ELLIS PhD program, and this is one of the, I must say, the jewels of the crown of ELLIS. This is an extremely successful program for attracting students that would like to do PhD research with some advisor from ELLIS. And then there's a fourth area, which is devoted to relations with both the European Commission, but also to the different organizations like the public-private partnerships. So let me mention a little bit more in detail these 3 main pillars. So the ELLIS sites, by now we have 41 sites in Europe, 41 units in Europe. We have an associate unit in Ukraine. And since a few weeks, okay, this is like a landscape of the ELLIS units. And this has been growing very quickly in the past 4 years. And since a couple of weeks ago, we have the first ELLIS Institute. This has been opened in Tübingen, and so you see some pictures here of that event. And ELLIS Institutes are viewed as the evolution of ELLIS units. So these are larger or more permanent entities which have a legal status, and they can hire personnel in the form of private principal investigators that may have joint affiliations with local universities. And so we see this as, if you like, a final stage of the evolution of the ELLIS units. So research programs, right now there are 16 programs that are, you see, they are made up of units coming from very many different countries in the ELLIS landscape. And they are focused on themes, on topics that are important and hot topics in contemporary AI research. So these are lines of work that are both foundationals but also applied, and are likely to have some strong potential impact in AI in the near future. So the PhD and postdoc program. So this is, as I mentioned, it was an extremely successful initiative. And the idea here, this is like based on one of the most fundamental principles of ELLIS. We want to reward talent, and we want to attract the best minds. And so this is really one of the best ways to do that, by creating a sort of a meeting point between the best PhD students in the world and the advisors, the best advisors in ELLIS in Europe. And this program is facilitating the matchmaking between students and their advisors. And this has been, we had three rounds, and we are going to have a fourth round of recruitments in November. And it has attracted a lot of attention. We had more than 8,000 applications so far. And this has already become a well-known program in Europe that people are, are willing to be part of. So, so let me conclude with a few milestones. So ELLIS has been, it's been existing only in the past 6 years. So we started in 2018. It underwent a very fast growth. So again, it's 41 units. It's a very large number. So we were actually surprised by the response of the European research to these initiatives. And how do we support ELLIS? How are these pillars being supported? They are supported in different ways, but mainly through European projects. So there are 3 European projects whose names are, recalling the ELLIS name: ELLIS, ELSA, and ELLIS. And so we are running out of names. But and it's also very confusing for the accounting because you never know what expenses go where. But these are really the project that will support the PhD program, that are supporting the mobility of the researchers, and they are supporting also the onboarding of the ELLIS fellows and scholars. So the people that make up the ELLIS network. And now we were very pleased of this last round of ELLIS unit approvals, of which Barcelona was part, and which just happened the last year, as you know. And so this is just to conclude. This is a picture to to thank the people that most contributed to this effort, which, as I told you before, I went through the whole so I know it's a lot of work, and I really would like to congratulate for all of you for this achievement and wish you best luck for the future. Thanks. Thank you.
Next, Dr. Demosthenis Karatzas, who is the co-director of the ELLIS unit Barcelona, will give a brief description of the unit.
Thank you very much. Consellers, secretaris, secretarias, directors generals, rectors, directoras, directors, ex-consellers, fellow researchers, thank you very much for accompanying us today in the presentation of the ELLIS unit Barcelona. So, highly innovative ecosystems emerge at outstanding academic institutions that serve as talent magnets and incubators of innovation. This is the phrase that ELLIS used back in 2020 to introduce basically what the idea was for an ELLIS unit. Right? And as Nicola explained, there are many units already around in Europe. And I think it's fair to say that Barcelona has always been in the map of artificial intelligence, I guess since Ramon Llull, but more recently, for the last 50 years at least, we've been active in artificial intelligence. And one thing that I think is important here is to stop seeing this as a set of disconnected sites in Europe and start thinking about it as a pan-European laboratory of artificial intelligence that works in this distributed way. Right? So Barcelona is part of that, and to have a dot on this map, it means that in this pan-European laboratory, it means that there is critical mass in artificial intelligence, that we produce excellent research, that we create real-life impact and that we have important artificial intelligence activity in the region. So, who are we? We started with 23 members that come from 9 different institutions in Barcelona. It's a multinational unit. We have, I don't know how many, 7 nationalities in the unit. We could have good gender balance, which is something we're proud of. And the most important thing of all is that all the members of the unit are actually outstanding researchers in their fields, recognized with 5-year grants, numerous research prizes, including Catalan and national research awards, awards from international research bodies, and also awards from industry. Right? So it's a pretty balanced curriculum that we have in the unit. Forming the unit would not be possible without the support from all the artificial intelligence intensive institutions in Barcelona. So the members of the unit stem from 5 universities and 4 research centers, all of them pioneers in different topics and fields of artificial intelligence. And these institutions act as the guarantors of the unit, allowing basically the researchers to participate and creating the best conditions for them to perform top-level artificial intelligence in their places. Having the support of these institutions is crucial. It's crucial to align efforts in artificial intelligence in Catalonia. So let me extend our gratitude, first of all, to the rectors and directors of all these institutions for aligning with us and allowing us to set this up. And of course, this would not have been possible without the support of the Generalitat of Catalonia through the departments of research and industry. The Generalitat of Catalonia is probably one of the first governments that approved the strategy for artificial intelligence back in 2020. Which, as Gina Tost explained before, comprises 4 different instruments that are supposed to push actions in different areas. SIDA is focusing on technology transfer innovation. EIAC is the Catalan Observatory of Artificial Intelligence. The DCA is bringing together the ecosystem of startups in the region. And the AIRA, the Artificial Intelligence Research Alliance, is focusing on actions that have to promote the generation of knowledge and the generation of talent in the region. The ELLIS unit Barcelona is part of the strategy, as in one of the key actions that is supported from the government through AIRA. Right? I know there's a lot of acronyms there, but I think it's important to make sure that we know where we are. So let me explain you a bit how the ELLIS unit actually participates to all the actions and the pillars that Nicolo explained just before me. The first thing is research, and how do we collaborate and coordinate basically with ELLIS in the different research programs that ELLIS has. So we currently participate in 4 of the research programs, and we expect to participate in many more in the years to come. And we are bringing cutting-edge, excellent research to these programs at the European level. For example, the robotics ELLIS program, which focuses on central questions for closing the real-world gap for intelligent systems. And to close this gap at the ELLIS unit Barcelona, we think it's important to co-design robotic assistants with all the involved stakeholders in healthcare. So in particular, what you see here, the 2 robot prototypes for cognitive training and for feeding assistance, these have been iteratively developed together with all the different stakeholders, physicians, nursing personnel, innovation technicians, social workers, and voluntary patients, and thus leading to an ethically driven deployment of these robots to provide personalized and continuously adaptive assistance. Right, autonomous driving. In autonomous driving, we're behind the development of Carla, which is the most widely used currently in the world driving simulator for training and for validating autonomous driving models. And once our models are trained, we're pioneers in bringing them to extreme conditions, right? So our own autonomous cars have been taken to conditions like what you see there, driving in adverse and unpredicted scenarios based only on very few cameras. we work on understanding humans in all possible ways, the way they move, the way they interact, their expressions, their sentiments. We're pioneers in modeling human behavior and also modeling humans in 3D based on very limited data. In the unit, we work a lot on human agency and the trustworthy deployment of artificial intelligence. For example, in the delicate scenario of decision-making for social services, where systems need to work together with humans and facilitate making decisions. So they do so by predicting human behavior, which in itself is a very uncertain and noisy thing to predict, right? So these are very difficult scenarios with very important real-life repercussions. For example, in the unit, we have worked with the risk-envy system, which is a model that has been used for the last 15 years here in Catalonia to predict the risk of recidivism and help decide whether people should stay in jail or not. Right? So these are real-life situations that have real-life effects on people. We also participate in key European projects in this space. IDEM is about bringing down the language barriers and facilitating the participation of people in democratic spaces. ELSA, promoted by ELLIS, is the European lighthouse for safe and secure artificial intelligence, looking into various ways of building trustworthy AI systems. Right? We're very active in multimodal learning. I think it's fair to say that in many ways we have been doing vision and language before this was called vision and language. And we're interested in language in many different forms. We build reading systems capable of reading text in the wild. We build systems that are capable of recognizing sign language in real time and generate sign language back. We're able to produce systems that respond to questions over large collections of documents. Right? And maybe one thing which is important is not only what we do, but the way we do it. Right? So in ELLIS in Barcelona, we invest a lot of time on open and reproducible research. We're behind a number of initiatives that basically facilitate people to have reproducible evaluations on open standards and open data. So very proud for this as well. So that was what we expect to bring on the research programs to start with. Regarding the second leg, which is the ELLIS PhD program, we already participate in this as well, and the whole point there is bringing and creating new talent in artificial intelligence in Catalonia. We already participate in the ELLIS PhD program, co-supervising 11 PhD students with a number of outstanding researchers from top institutions around Europe. And we expect to get many more now that we have formed the unit in the years to come. And of course, we are open to collaboration in creating new talent with industry as well as academia in this respect. And, well, looking back to the site itself, what should we expect from this unit? What's going to happen in the future? So we will be working on a number of different things, organizing a number of activities, seminars open to everybody, supporting the organization of machine learning-related scientific events in Catalonia, collaborating with industry and academia, fostering mobility, both of Catalan researchers outside and bringing excellent researchers in, and a large, etc. Over the past year, we have already been active on this, and the ELLIS unit has already supported and co-organized numerous events related to machine learning, conferences, meetings, and symposia and summer schools, and we will continue doing so in the future. And starting this September, we will initiate a new series of ELLIS seminars, where this will be open to everybody, will happen in Barcelona, and we expect to bring top researchers from the ELLIS network to Barcelona to speak about the research and visit the local laboratories of artificial intelligence here. So watch the space for details about the seminars. The first one is this September from Nico Sebe, from the ELLIS program on multimodal learning systems. So with this, I will let you enjoy a short video about the unit. Thank you very much.
Welcome to Barcelona, a wonderful city to live in and to carry out research in artificial intelligence.
The ELLIS Unit Barcelona has been created under the auspices of the Catalan government and with the support of the 5 major universities of Barcelona and the 4 public research centers focused on AI.
Catalonia has a long tradition of research in artificial intelligence, with the Catalan AI Association celebrating its 30th anniversary precisely this year. As a result, Catalonia is the 3rd region in Europe in Horizon 2020 AI project participation.
Research has crystallized into a vibrant, worldwide recognized ecosystem of innovation in AI. The commitment to turn this ecosystem into a leading European AI research and innovation hub led to the Catalonia AI strategy approved in 2019.
The Barcelona unit brings together 21 outstanding researchers, weaving strong synergies between fundamental and applied areas of machine learning, such as human-robot interaction, human behavior understanding, safe and secure AI, bioinformatics, medical imaging, and living labs and open innovation.
Between the Barcelona ELLIS unit members, we have created, to this date, 10 spin-off companies based on AI and maintain important links with local and international industry.
The contribution of current fellows to 3 ELLIS programs, namely robot learning, closing the reality gap, human-centric machine learning, and interactive learning and interventional representations, is just the tip of the iceberg of the enormous potential of the unit to widely contribute to and create synergies with other programs.
With a common emphasis on the friendly interaction of AI systems with humans to promote their well-being in fair, egalitarian, and healthy societies.
We are currently at a crossroads in the development of artificial intelligence, and the ELLIS network offers a privileged opportunity to develop machine learning in an ethics-driven, beneficial way for humanity.
The Barcelona unit is committed to carry out research, innovation, and also influence policy making towards this goal. Well, now we come to the last intervention, or it is an honor for the ELLIS Unit Barcelona that Dr. Oriol Vinyals accepted to deliver this inaugural keynote speech. He's an ELLIS Fellow, Vice President of Research at Google DeepMind, where he's currently co-technical lead for Gemini with Jeff Dean. Let me mention that he studied at UPC here in Barcelona, where he obtained a double degree in mathematics and telecommunications engineering in the CEFIS program. He obtained his PhD in electrical engineering and computer science at the University of California in Berkeley and joined Google Brain in 2013. Transitioning to DeepMind in 2016, now Google DeepMind. Oriol's research has been featured multiple times by the New York Times, Financial Times, many times, Wired, BBC, etc. And his articles have been cited over 275,000 times. Some of his contributions, such as Gemini, Seg2Seg, knowledge distillation, or TensorFlow, are used in most Google products, serving billions of queries every day. He was the lead researcher of the AlphaStar project, featured on the cover of Nature, creating an agent that defeated a top professional at the game of StarCraft and achieving Grandmaster level. Oriol also contributed to the research and papers for AlphaFold, an AI system providing the solution to the protein folding problem, a 50-year-old grand challenge in biology. His talk today, entitled From AI to AGI, the general intelligence that Teresa Cabré was mentioning, the quest for true intelligence, and will touch on LLMs, large language models, a technical concept which recently turned into an almost everyday word. And I bet we all want to know what Gemini will bring about in the near future. The floor is yours, Oriol.
Bon dia. Faré la xerrada des d'allà, però volia dir unes paraules en català donat on estem. Primerament, moltes gràcies a tothom per venir. Felicitats per obrir aquest centre d'elit tan important per la ciutat i pel país. Evidentment, moltes gràcies a la Teresa, Carme, Laia, Gina, Nicola i Dimos per convidar-me. Abans d'anar a la tarima, tot i que canviarem a anglès, espero que amb un nom tan català em perdonin els que estiguin aquí de fa molts anys. Però vull fer una selfie també per recordar, no ho faig a cada xerrada, però les que són especials m'agrada fer-ho. Estic intentant l'angle. Perfecte. Vale. All right, switching gears. All right, so thank you. Okay, if we can switch to my laptop, if it works. Oh, it doesn't present the right, of course, technical issues. Let me just make sure I'm double the screen. Interesting. This worked before, I promise. I'll tell you an anecdote. So Karma and I are connected through more than ELLIS. It turns out that my parents know her sister. And I was trying to argue with my parents that this is not fully random, that there's a graph of connections and some biases. But anyways, I tried that yesterday night. It didn't work out too well. But anyways, let me see if we managed to do this. It's my laptop's fault, so apologies. And yeah, as it was said before, I just need to find, this never happened. Okay, I think I know. I need to just double the screen. Oh, maybe if I present, 1 second. No. Oh, wow. I mean, this is my background. So like that's something you learned so far. I hope you learn more. Oh, okay. No, that's different. Let's see. Okay. Can we, let's see, it's still, say, I'll do something a bit, okay, I think this will work. It's a bit annoying, but let's go back to my screen. I'm just moving to the screen I don't see here, but that's fine. Switch back to the HDMI, please. Okay, and now I have to find my mouse, which requires AGI. Okay, great. Amazing. So yes, I'll try to maybe answer Teresa's question on explaining what is AGI versus AI. Before, I was just congratulating everyone for this amazing moment. One thing Laia, I believe, didn't mention about Barcelona is that Barcelona is a pretty nice place to be, you know? It's I describe this to some people in California as it's like California, but 10 times smaller. And I think, you know, that's not to be, you know, underplayed. You know, a geography is not something you can easily change. So whether the amazing culture, amazing food, amazing people, right? Let's not forget that when we sell Barcelona to the world. Great. Another huge acknowledgement is that I'll present some work, some of which I was involved, some of which I wasn't. But it is extremely important to recognize that all the work we do, as the program itself tries to emphasize, is as a group. So I just want to make sure that you don't think I did all this alone. There's a lot of people that contributed, and I'm just maybe the tip of the iceberg today, because that's all you see. But huge love to all my collaborators and advisors and so on. All right, so let's go to definitions. Today it will be a little technical, but not super technical. I hope all of you might get something from the talk. And at the end, if there's some time, I'm happy to answer questions and of course hang out at the end of the event. So this definition is fairly well accepted as what AGI is. So an artificial general intelligence is a machine that can do the kinds of cognitive tasks that people can typically do. And then I expand cognitive tasks. This is just a standard definition. But in this definition, what I like is that there are concepts like acquiring and organizing new knowledge and learn. Many of these keywords, of course, present in the ELLIS acronym, as it should. And I think this actually is a pretty good definition. And I'll try to explain a bit historically what has been happening and where ELLIS can play a future role, and of course, where we're coming from and what we might be going to. And at the end, I'll try to give you an estimate of when AGI might be achieved, but throughout the talk, I'll build out some of the key ingredients and moments and research breakthroughs that have occurred that makes us believe today that we might be closer to this quest, which if you think profoundly about humans and humanity, intelligence is our maybe most defining trait versus other species. So being able to build an artificial intelligence or general intelligence at the human level is perhaps one of the greatest endeavors we've embarked on as a species as well. Great, so let's start with AI, not G, right? This is artificial intelligence. I call this the deep learning era, and we've heard the word deep learning. So let me try to describe how a talk like this would have probably been a few years ago, right? I would probably have gone into how many amazing things are either on the verge of a breakthrough or at human level, such as recognizing objects in an image, translating or transcribing from speech to text, translating or describing images in more rich sentences, right? And there were systems being built and improving upon state-of-the-art day by day, year by year on all these. Interestingly, there was also an emerging trend. This era maybe spans from 2010 to 2020 or so, going the other way around. Sometimes it's trivial. Of course, translating is very symmetric, but we have also seen many breakthroughs in generation of images from text, speech from text or from pieces of audio, etc., etc. Now, diving a bit deeper into two of the key moments that Google DeepMind is probably most well known for, AlphaGo is a system, a single system that can play the game of Go at superhuman level. This was one of the key moments in AI, probably after beating Kasparov many, many years before this moment. And the system, no need to explain how it works exactly. It uses learning heavily, which is kind of an important aspect of the current bet into deep learning and beyond. But this system couldn't even play chess, right? So, or even 9x9 Go, which is a sort of simplified version of Go. Usually there's 19x19 positions in the grid. Yet it was one, of course, of the biggest achievements. Another one is AlphaFold. Again, it's a specialized system that is trained to transcribe a sequence of amino acids. These little letters there are reasonably cheap and fast to extract from a protein. So that's not the bottleneck. What's very hard then is to figure out what's the three-dimensional structure of this protein, right? That takes generally a full PhD to extract one of these from data using crystallography and some methods that require quite a lot of work. And what was done in AlphaFold was to learn this mapping from the sequence of letters to the three-dimensional structure And that was sort of one of the breakthroughs, as was mentioned before, that now enable a much faster research pace in many areas of biology. And this is important because these 3D things, right? Like there's proteins that are, let's say, part of a virus, like the coronavirus. Everyone probably has this image of the little spike, so that's a protein. So to create or to accelerate research into curing diseases, for example, you might want to explore medicines that would maybe affect the structure of the virus in a way that it makes it less viral, right? So lots of research and iteration now is being built on top of AlphaFold, as this also was open source for the community to build upon. But these and many more examples from like last decade, even AlphaFold is not from last decade, is that all these demonstrations, right, were focusing on models to excel on one task. Play the game of Go, forget about even chess, fold proteins, but that model can't do anything else. But what was general is that the technologies, how we build the solutions for these problems, that was heavily reused, right? So neural networks, stochastic gradient descent, supervised learning, reinforcement learning, all these pieces of the puzzle could be combined in different ways depending on the one task we cared about to solve. And generally, you would advance that field quite quickly by focusing hard on developing the algorithms and then creating a single model that could do one of these tasks extremely well. But the models themselves, I'll insist, they're not general, so they don't have the G. That is part of what AGI definition entails. Put another way, lots of advances on architectures and tricks. Of course, these are just a few, and very deep learning sort of bias, but there's many advances. You create all these technologies to deal with different data, input data, output data, lots of data, scarcity of data, etc. Mix and match, and generally success is guaranteed in the one task that you get your hands on very good evaluations and data sets. Then you can build pretty amazing systems, as I've been saying. So in our quest towards AGI, it was pretty clear to most of us that we have very powerful models that are very general, that can be trained very efficiently to do that one task. That's one piece of the puzzle, more zooming out towards the quest to true intelligence. Now, it is important to zoom out and say, well, okay, these are great models, but how about the generality that we all were dreaming about? How do we bring the G back to AGI? So for this, maybe unsurprisingly in hindsight, language has been a key enabler of extreme progress that we've had in the last few years. I think this is sort of pretty profound because the fact that language enabled the breakthroughs that I'm about to describe is quite convenient because it puts us at the center of the technology, because we can actually then manipulate the systems, as many of you might have played recently. Had it been a system that was harder to interact with, it would be very powerful, but we would have to build channels to talk to the system rather than the system itself operating in language space. So this is a pretty key observation, and maybe, again, lucky or coincidence or not, but it is important to remind that thanks to this, we can interact immediately without any pain, and all of us experience the technology without as many barriers as if it had been something a bit more technical. Now, the key idea is just to predict language, right? That's sort of very classically proposed many years ago. In fact, Shannon, who is the inventor of information theory, already was dreaming about a machine that could generate language through some pretty simple mechanisms at the time called n-gram models. But then beyond that, we started sort of putting more machinery, more learning on top of pretty simple techniques initially that just use statistics of word occurrences to then actually learn the correlations of how text and sequences of words are being formed. And you can see this by just reading the text, where initially what Shannon could sample was pretty nonsensical. You get Mexico and Brazil, which, okay, as sets of 3 words, might have written this. And then, of course, the last kind of set of breakthroughs were enabled thanks to a technology called transformers. And GPT-2 popularized this probably sharply, but there was a paper a year before that already was saying, how about we give you a Wikipedia title and you get one of these language models to generate all the contents and see how coherent this content comes up to be. And of course, that is the premise of the breakthroughs that are large language models. Before I describe a few key moments in time in the past 5 years or so, I'll just insist that part of the research needed was, how do we take in sequences of words, like language, and map it to predicting what's the next word, right? That's all we do. We'd say, given what Oriol said, what's going to be the next word? There are many possibilities given by the context, et cetera, but that mapping was a pretty tricky business in even deep learning because of the variable length and other properties of language. And Transformer is one of the many architectures and variants that have been sort of built on with research programs from many decades, and of course with lots of hindsight from academia to start iterating over these, that are just extremely powerful for what language requires. No equations, because I'm skipping that slide, but I hope you forgive me. So let's look at that GPT-2 moment, okay? Many will think transformers was the key enabler of the current LLM breakthroughs, but to me, the main contribution of OpenAI GPT-2 was the insight of training on all the data on the internet, okay? That sounds not even that obvious why that would work, but that is probably the key innovation I would attribute to the whole GPT series. And in the abstract of the paper, the GPT-2 paper, which had models that were already of reasonable size, 1.5 billion parameters. Billion, I think it's 10 to the 9. I think here it means different, maybe it's 10 to the, anyways, it's 10 to the 9. And it trained on many words on all of the internet, not really all of the internet, but a subset of the internet, because training over such large corpus is, of course, very computationally intense. And if you read the abstract, you start seeing motivations that start to align with that definition of AGI, right? So it says, using or training over all the internet these very powerful language models, we can start seeing good performance on a variety of different tasks, which otherwise would typically be approached with supervised learning on task-specific data sets, right? So the paper already sees, look, I train on all of the internet. I become quite good at all these specialized data sets that the previous decade we were sort of climbing performance on. And the coolest part is, of course, that these language models exhibit this property without being even trained on the training sets of those data sets, right? So this emergent behavior, some people saw this and decided to test these hypotheses further by then scaling them up. And many of the models today, including, of course, Gemini, are testing that hypothesis of scaling up this basic idea. GPT-2 by itself was not extremely impressive in performance, but the insight was there already. And then what you see after that, and maybe much better representation, is that we're entering a new era where we're scaling these already massive systems over cycles. This is a very cool plot. Many of you might have seen. There's so much cool information here. I'm going to highlight a few key pieces, okay? First of all is that, well, look at the year, right? So this spans basically from actually that Shannon moment, the early moments of AI and machine learning to currently. You see, and then the y-axis is how many flops, what's the computational intensity used to train a model, which correlates with the size of the model and the size of the data set in some pretty trivial fashion. But you can, and it's logarithmic, right? So every point is 2 orders of magnitude, it's not linear, which tells you the usual graph you might have seen more historically is that computational power doubles every, I don't know, 2 years or something. This is the same, but in terms of what is the investment to train a single model used. And then you see sort of a trend that's reasonable over many decades. Then that deep learning era, there was a ramp up of the computation intensity to train that single system to do something amazing. Partly thanks to this is GPUs and hardware available and data sets and many other breakthroughs. But then what emerged is that this new paradigm of training extremely large language models shifted or created a secondary graph, which is the red one on top, which is at the levels of 1e to the 24 flops. Now, another interesting fact here, you might not be aware, it is important to think carefully about these systems from a societal impact point of view. So, for example, the White House in the US has asked anyone training a model that spends more than 1e26, so that's a bit higher than the top bar, to declare and explain what the model is about so that it can be properly analyzed by, in this case, one of the, of course, powerful world entities. So there's a lot of thinking about regulation and how to understand these trends, and 1e26, this is a bit outdated, is already occurring in some labs. It is not cheap, though, I will say, but it is extremely powerful what these models do, as I'll explain, or I'll show you some demonstrations following. And then again, the hypothesis of scale, seen in different ways, is that these models are initially not even that great. That's why maybe this was a bit under the radar. So you can evaluate these models to do all sorts of different language tasks, and only after you train them for 10 to the 22, there's sort of a mode switch where the models have learned that task just through looking at data on the internet, without being explicitly, of course, trained on that particular one task, which is what deep learning was doing the decade before. So this is what makes us sort of keep pushing the x-axis to see what new capabilities will emerge as we keep scaling up these models. So going back to our nice picture, this is AI generated, by the way. We have powerful models, and now we have general text models, right? These models can do many tasks that involve text. You can ask them to do things. With many of us, this has become extremely mainstream, so it's probably not needed to explain, and I'll have some examples more advanced later on. But second key moment for bringing back this G back into AGI is that we have now general models operating over text. So another key piece, and I know that's of course part of the research ongoing in ELLIS, for example, is multimodality, right? We learn language, but the world is more than language. There's sound, touch, and of course, sensory modalities we get through our vision, mostly, of course, static images and three-dimensional movement and video. So a key piece of work that we developed, this is one of the earlier visual language models, which we published in 2022 called Flamingo. We got very creative with names at that time, is to just interleave the idea of, hey, we can train on all the language on the internet, but wait a second, the internet also is full of images. How about we just train on all the data, not all the text on the internet? You need to really carefully create a corpus of all the internet, which now is not only just the text that you see, but also the interleaved images. It's quite non-trivial, and it's quite important to get the data sets correctly formatted. But what we did is combine a few data sets, some of which had only text, some of which had text and images interleaved, And then architecturally, we did just some tricks to add a vision encoder and basically take a model that was very good at language already and freeze its brain and just inject in every layer, right? Deep learning comes from having many layers stacked, inject sort of these little information channels that come from the image portion of this particular training sample, right? So you have image, this is a very cute dog, cat, and this is, and then what the model is trying to predict is the next words, like a very serious cat, but it's not only using the words, it's also using the context, which is the vision channel as well, which of course informs what the next words are going to be more richly than if we just had used the text from that input. So that's one approach we developed, and actually in parallel we developed another approach which we call Gato, which is what it is. It's an animal, of course, but it's also a model we trained, where the insight we use there is slightly different. Instead of having a vision encoder and injecting it into a language model brain to use that information, we simply say, look, images can be represented as sequences of symbols. If you think of when you compress an image to a JPEG, it's just a bunch of bytes that are sent to the internet, and then you can decode them into the nice image you see. So there's a technique very similar to that encodes images into like numbers, and then you can think of those numbers as text, right? So your modeling problem becomes even simpler conceptually, right? You just say, any data that comes in is not text, is not images, it's just bytes, right? Bits ordered or grouped in some fashion. And then you train using exactly the same code and the same principles that you did using language models, but now these become multimodal. And I explained this variant of multimodality just because Gemini, which is of course the flagship model that we've been developing at Google, uses this principle mostly to create some of the amazing capabilities that we've opened for the world to experiment in different products and surfaces for developers. So zooming out, Gemini takes in different modalities, text, audio, images, video, then uses a transformer and predicts an output to generate text mostly. That's mostly the use case we use today, although it can also generate images, but it's not going to be the focus today. And just with this, and training and scaling up and perfecting all these ideas over the years, what we released last December, so we're starting to be timeline-wise very short term. The Gemini project itself starts a year plus ago. It's not that old of a project. But we created this model training on the Google infrastructure at very large scale. And then you start seeing, of course, people using it in many different ways. This is a very interesting example. It shows a bit of all the things these models are able to do. So you just say to the model, here is a solution to a physics problem by a student, right? Then you take a screenshot of the piece of paper that the student wrote its solution, right? So there's, of course, first there's the problem statement, is some sort of, I actually wouldn't know how to solve this, embarrassingly, but it's some sort of physics problem that you probably learn and then sadly might forget. And there's the handwritten solution from the student. And what you're actually asking the model to do is not to maybe solve this for you. You're actually asking, can you reason whether this solution is correct? Can you give me some hints why it might not be correct, et cetera, right? So the way you start interacting with computers becomes not through programming, but through language and images, which is, again, the coincidence or not that I mentioned before, which makes it extremely accessible for the world to then try any ideas. And you just have to think there's a brain that essentially understands what you're asking it to do, and then it replies with some mistake. In this particular case, it understands all the text, all the pixels, etc. in this particular problem. And of course, it's not perfect all the time. This just exemplifies what multimodality buys you and the kinds of new things you might be able to unlock thanks to doing this. Now, interestingly, we use the deep learning era benchmarks as a way to test the generality, which is a very extremely convenient way to go about it. So we have all these specialized tests that we've built over the years, very carefully built evaluations for different capabilities that people were building specialized models for. And the usual way you then evaluate your general model is to say, how well do you do on everything we as a community have built? And in some cases, you're state of the art. In some cases, it might not be state of the art. But the point here is that the model is general. There's just one model. You just instruct it to do the task that the researcher, maybe in some cases, many years ago thought about. And the models become good, and importantly, they keep improving every few months, right? So this is sort of, now you're climbing the ladder of every single cognitive task that we as a community build, which again resonates a bit more with that definition of AGI. There's many modalities, and I mean, the numbers keep changing. This is super outdated because it's 6 months old. So no need to look into this. But building up, we have now not only general text models, we know how to build general multimodal models, okay? So are we done? Not quite. One of the key, when I gave a similar talk to, I talked in Stanford like just a month ago, someone who is a linguist, Chris Manning, said what they don't like about the definition of AGI is that it doesn't emphasize the act of learning, okay? But it actually does, because you can think of the task of learning as one of the tasks we must test our systems to do, right? It's not only that this model knows the things we already know about physics, is that if there's a new mathematical area, you would like it to teach it to it, like you and I might teach each other over time. And that capability requires slightly more than what we had up to now. And of course, it's not at all soft, but the part that I'm very excited about in terms of frontier is the ability of the model to just learn on the fly or meta-learn or whatnot. And I'll just explain this for those of you who are interested. And that will be enhanced thanks to a breakthrough that allows our models to process more information in the length of the sequence it consumes, right? So RNNs or LSTMs, which was the previous generation of transformer in that table, were perhaps able to remember 100, 150 tokens in practice. Mathematically, they can remember infinite amount of information, but that's not true in practice. Transformers are extremely high bandwidth to everything that they've seen in context, right? So you could imagine showing more and more things in context to the model, right? Giving that homework example, maybe that's a few hundred words and the image maybe contains 500 symbols or so. But that's just a limited amount of information. And most models up to February, when we release 1.5 series of Gemini, so that's February this year, most models could do maybe tens of thousands of tokens in the context, which is pretty good. That example fits in the context. But of course, that's one axis of improvement clearly for these models. And I'll explain you why through a pretty cool example, I think, of what these models can do. But one of the key things we innovated here is to make the context length, which prior to February was at best maybe 100,000 tokens, to up to 10 million tokens. And of course, that's just a step towards infinite in practice. And there's a few ways you can test this capability. I will skip this one because I don't think it's the one I'm most excited about. The one I'm most excited about is when you think, right, you're going to your favorite chatbot and you say, hey, I want to cook something or whatnot, right? That's very short amount of instructions. But if we want to develop a new mathematical theory, we probably need to have a pretty long conversation that spans many, many, many words, sharing books, research articles with the model, et cetera, et cetera. That context needs to be ideally infinite. And you're going to upload all these into the working memory of the model. The model is already trained. And so it turns out that this is similar to what we were trained to do with meta-learning or few-shot learning or in-context learning which I think touches on the key capability that was perhaps missing in the AGI definition. We learn new things. There's a new vehicle, there's social media. We're all learning, right? Like all sorts of new technologies. The world is not static. So that capability needs to be in these models. And to learn, the way that mathematically you express that is that you have a set S that is kind of the knowledge you're meant to learn, and then you're trying to make good predictions about that topic. And that can be the prompt, right? So you say, hey, like, learn this thing, and then you upload it to the model context and hope the model now has learned whatever new game you invented or anything, right? And again, the longer that context, the more complex things the model can learn. So one of the cool tests that I really love, and it's pretty intuitive how this might work, is that there's this academic benchmark that consists on the following. There is a language called Calamang spoken by extremely few people in the world, 130, and it almost has no online presence, right? So you train on all of the internet, but that language would not be really present in your training corpus. But luckily, someone who likes this language wrote a book about all the rules about the language, right? So you can imagine someone studying this. I believe this book is like 600 pages long, and someone passionate about this language went and wrote an English book about rules of the language, et cetera, et cetera. Now, we converted this into a benchmark, or this work, rather. It was not us. We just took this because we like this benchmark, in the following way. We say, look, could a model that has not seen this language learn this language? And the way you do it in, again, modern machine learning and computation that we are today is you take the book, you upload it. You say, this is your context, that's the S, okay? So you take all this book, upload it. Also that you take a dictionary, which of course is not enough to translate. As you know, you cannot just translate word by word, but that's also information that is given to the model. So you take this pair of knowledge of something the model is not aware of, and then you just ask the model, literally in language, this is the exact prompt. Given the reference materials as context, then you ask it, translate the following sentence from English to Calamang, which is a language you've never seen, and then you just basically write whatever you want it to translate. And critically, the model is seeing all this book, which it has never trained, it hasn't trained on this book, et cetera, and you get a translation out. And it turns out that this works pretty well. Again, this is too technical for some, but the TLDR is that the model, because it can see the context, imagine a model that only can see 10,000 words, it would need to truncate the book, so it wouldn't be able to read the whole book. And we did test, how about you never see the book, how good you are, and then you get a 0. Think of that as a score, that higher is better. And then the more of the book you see, if you see half a book, you get 4, and if not, you get 4.4 in either direction, from Calamang or to Calamang to translate. And what's cool to see is that if you ask a human language expert to read this book, which takes obviously some effort for this human, the performance is a bit better, but you can see this model, which does this, of course, in an instant, right? You just upload the book, say, translate this for me, and the model just learned that. The performance starting to close, the gap is pretty close, and of course, this is just the first iteration of a model that can actually be uploaded whole books and more materials that we again, released for anyone to try back in February. So I believe that long context allows you to learn more complex tasks. That is also being actively worked by the community, lots of advances. So these 4 start to feel like we are getting pretty close to achieve reasonably confident levels of that initial definition of AGI. And I'll get back to that in just the concluding remarks. Right now, what we can do is just look at some examples to get a feel of what the model can do, okay? So let's see if this works. Anyways, the first example is skipped. It doesn't matter. I don't have internet, and Google requires internet for presentations, interestingly, or unsurprisingly. But this is an example of we gave this access to developers in February, so people have been playing with the model, how capable it is. And someone just took a camera, pan it through their books, the bookcase of all the books they have, and then they're asking the model, hey, can you just give me the JSON array of books in this video? That's just a particular data structure. And that's, again, done by someone. This is usually, you just go to Twitter and look for how people are using the model, which is pretty cool. And just from the video, this is a task that the model has not been trained to do. You just ask it, can you do this for me? The model sort of does this pretty well, which is pretty cool, right? This is not a very particularly long video. Something else that someone was trying is, there's a YouTube video with all the most famous sports moments in the US, which is 11 minutes long, which is not that long, but you just ask it, hey, can you give me a bullet list of the key moments in US history according to this particular video? And again, a few seconds later, you just get this list, right, with the dates. And of course, you could ask the model to change the format, to explain more, to explain less, right? This is all basically a super assistant for this user that cares about this video and can upload many more things. And you instantly get pretty accurate results in general, of course, not always. And then maybe the most extreme one, sadly, I thought I had internet, but okay, I don't. But this one is pretty insane because this is a user that takes the phone, has some code on the screen and just says, look, I'm coding, this thing doesn't work, points the camera and literally asks, can you just help me fix this code for me? And then the model basically helps, right? So this is pretty wild, the world we're entering, where we have at our hands these capabilities that, of course, many years ago we couldn't even think about. And this is not only, it's not the beginning, because as I showed, there's a long history of course, research ongoing. But certainly the technology is advancing fast. So if I gave this talk in a year, I'm sure there would be even more capabilities and amazing things that we would find these models are getting pretty good at. So let me conclude with a few challenges, especially those for maybe looking to work on things that we, as some of the few players that can actually train the largest models in the world, struggle with from a research point of view. First of which is evaluation, okay? It turns out the internet is pretty large. So actually, most of the data sets that were built for machine learning, well, they are on the internet. So you're starting to be in a situation of training on your test set, which is not great. And of course, many of us are trying to decontaminate or just check, hey, let's remove this piece of the internet because it just has the exact test set. But it is pretty challenging because you can format things slightly differently. So this is a massive problem on how to compare then what the most capable models are doing. Luckily, there are other ways people are, again, thinking about evaluation of language models, one of which is as simple as it's a game. Anyone can go to this website called LMCs, and then you just ask the model something, you get 2 replies from 2 different models, and you as a user will vote which one you like best, and then a leaderboard is created with, this is the most recent, I believe, leaderboard with the ELLIS score like you would do with chess players, okay? This is a bit better, it's not perfect either, but evaluation is very hard and something that academia has been building for years, and I think we need to sort of challenge a bit of the current paradigm, but slight modifications might go a long way. Then I picked these other sets of challenges just because I think this is good news for academia. Post-training is you have this massive model trained, and then you can iterate on it a little bit, test its capabilities by prompting or by training it for a little bit longer. Luckily, many labs are open sourcing or opening some of the models at a smaller scale for academia to, of course, study them. Google obviously is doing that. The latest iteration is Gemma, which in that leaderboard is actually pretty good. It's pretty competitive, so it gives some resemblance to the most capable models of how they might behave, how might they fail, and so on. And then many challenges remain in post-training. For instance, you usually want the models not to just imitate all of the internet, but then align with user values, right? So for that, you basically ask users, is this a good reply or not? And you just train a classifier, that's your reward function. But it's pretty tricky to get humans to agree with one another. I think it's pretty clear, given many debates, and it's fine. We are in a very diverse world and very global. But the point is that challenge transfers to models. I mean, are you going to create a model that everyone in the world agrees with or likes? Right? We're seeing all of these challenges in society. It's very interesting, very challenging. So that's one area, for example. I'm not going to read the other ones, so we can have a few questions or discussions, but I'm almost done. But again, highlighting some of the things that are challenging. Safety of the models, bias of the models, that's a pretty, that's basically challenging. I don't think it will ever be solved, but then you need to iterate with society, like what are these models are or aren't. Reminds me a little bit of they say, don't believe everything you read on the internet. I think society sort of, that's been common knowledge now, but you shouldn't believe everything these models say either, right? So there's a bit of learning, right, between the technology and then, of course, how it affects the world. Again, factuality, hallucinations, common problems, all the models have it to some extent. You can, of course, attack the models to say things like 2 + 2 = 5, and then some people get some likes on Twitter, which is a reward function for humans, apparently, et cetera, et cetera. So there's many, many, many challenges remaining. That being said, and Shane is a co-founder of DeepMind, in 2009, he had this prediction that by 2028, he believes there's a 50% chance of AGI by some definition of, it's that definition, but then the test needs to be a bit more strict than just some words, which is pretty interesting because I think the world agrees, right? So this is my last slide. There is these websites where people make predictions on topics, right? This is kind of worldwide marketplace for predictions. There's 3,000 predictions, and over time, you see the belief of AGI being achieved by such year, right? So the way to read this graph is, look, in 2021, most people in the world believe by 2050, AGI is achieved. Now, of course, that belief is updated given results and evidence. So at this point, right, this trend of belief, and it was obviously even higher than 2050, just before that. But today, this is actually closer to 2032, the median prediction. Some are pessimists, some are optimists, that's okay. But you can see it's like technology is there, it's pretty impressive, we need to get ready. But of course, I think the opportunity is pretty exciting. I see this as another internet level, or maybe mobile phone era, or industrial revolution was mentioned. So this is going to be pretty profound changing of our society. So I applaud, of course, the city where I'm from to invest heavily in it, as we heard. So again, thanks everyone, congratulations, and happy to answer some questions. I believe we have 5 minutes or so. Thank you so much. Okay, let's do questions. There's one there, actually.
For the talk. That was really interesting and really, I don't know, really provocative. So I usually go to negative consequences of AI from the side of fairness and ethics, but I want to take a different approach today, if I may. So what I'm seeing is the mass production of low-quality informational products. So for instance, if today you look for the meaning of the lyrics of a song, you don't find the meaning of the lyrics of this song written by a human. You find like something very blunt written by an AI. And the same is happening with translations. Like many companies are opting to provide translation of the website, like they provide a low-quality translation, or even like journalism, right? You find short news items that look very blunt and so on. And I have this feeling that we are kind of stuck with that. For a few decades, we are going to enjoy mass-produced, low-quality informational products. And I know your team cannot control the fact that these mass-produced, low-quality informational products are built. You can improve the quality of the generator. But I feel that we're stuck, just as we are stuck with mass-produced, like low-quality apples or strawberries or the rest of things, as we know. And we know the difference between the mass-produced product and the other one. So that's my question for you. Do you think you can? Do you have the same kind of concern? about the adoption of these tools to produce these mass-produced low-quality informational products or not?
Yeah,
and thanks for the talk again.
Yeah, yeah. It's a very good point. There's definitely, like, it's very concerning for different aspects and angles, even from the mundane one that when you train these models on all of the internet, if all of the internet happens to have these contents, that's actually a challenge and it decreases the quality of the model. So even from that side, it is a worry. But of course, Google is large, is not everything, but what Google, for example, is trying to do, and that's also one of the research that is pretty recent. How adopted this will be is tricky, but of course, one is the search engine, right? You just need to be very careful with ranking of information because people have been using Google search for decades, and ideally they want to trust what they read. So that's an ongoing challenge and lots of improvements to be built. The thing that makes me a bit more positive about this is that we found a technique that you can watermark the content generated by an AI, okay? So watermarking is just hiding some hidden bits of information in images, for example, to know, hey, this was not an artist that did it, this was an AI that did it. And it's pretty robust on images. It's been done for decades for copyright reasons, but also in text, we found a way to do it by essentially changing slightly probabilities of certain distributions of words in a way that then you would be, hey, this text, this news article is actually AI generated. Of course, you might feel free to read it, it might be entertaining and so on, but at least knowing what you're reading is generated might be quite useful for the problem you say. So we open source that. It's called Synth ID. You can go and find it. The technology is not perfect, but researchers as well, of course, will build on top of that approach, hopefully. And then how you control that, well, you can imagine Chrome is a browser that's pretty popular. So now Chrome can embed a little thing that says, like it says, this website is secure, right? There's the little log. It could say, careful, this video you're seeing is generated. So just when you think about who to vote or important things, at least from the Google surfaces, and probably companies that are reasonable will adopt this. It's not solving the problem, but I think there's definitely active work, not only worry about it. That's what I'm trying to say. But yeah, good question. Any more questions? Yeah, here.
Hello, thank you for the
It works, it seems, well,
okay, thank you. Yeah. Thank you for the fantastic talk. I wonder your take on, maybe we can say, the artificial intelligence divide between prosperous societies and non-so-prosperous societies. So what is the take of...
Sorry, I didn't hear. So from which societies?
Very prosperous societies, like the European one or the American one, versus less prosperous societies on the use of this technology and the availability of these technologies and to break the digital divide.
Yeah, I mean, that's another good question, right? There's the values, like human values, human rights. There's different interpretations or different approaches, and the world is very big and not everyone sees it the same way. So that's probably even more tricky to, at this point, to do anything about. I mean, this is geopolitics, right? We're entering, it's not only about the AI. I mean, there are obviously other technologies that are used, and governments choose how to do that. I think as a researcher, the tools we have, and we're starting to really think seriously about this, is obviously how much do you disclose from these more frontier techniques openly? So, for example, we open models, but probably not at the frontier models. We might not open those so that the use cases remain at least restricted to some extent. And that's in part probably why the White House asks, hey, models that train above some threshold of compute, we want to know about that. That's not to say that obviously that government is the best in, I mean, look, nothing is perfect, right? But I think the point is, as a researcher, being open is very important. It was mentioned earlier, but also you start to modulate these risks. That's what we can do as research institutions, or even we're doing obviously research from industry. And then other tools that exist are very real. For instance, there is a ban on exporting GPUs to China, for example. Then NVIDIA cannot sell GPUs to China, right? That means that that curve you see is a bit more challenging for, I mean, that's a choice. I don't want to make strong statements, but there are then more political and other interventions that, depending on the information and the knowledge about these models, the world might take. And again, there's a lot of unknowns, but yeah, this is also very top of mind for many of us, most of us, I would say, which is good news, but also doesn't mean that it's going to be solved very, very trivially. Good. Maybe one last question, but otherwise, I don't want to get in the way of lunch. Yes. One. Oh, there's one. Oh, here. Also. Sorry.
Yeah, very nice, very interesting talk. I just wanted maybe you to comment on this sort of dichotomy between fine-tuning, so taking a foundation model and doing a specialized training on some task, and what you mentioned in context learning. So I'm just giving you a lot of context, but which will go away after. So it's a sort of
yeah.
There's some probably
yeah, it's a beautiful problem, especially when we were more actively researching meta-learning. I typified these two methods as one is you have maybe a small data set of new knowledge you want to inject or learn from. And of course, deep learning requires a lot of data, so that was hard at the time. But you can be model-based. You can just give it to the model as context, format it correctly, make it like a textbook, maybe interact with the model, teach that new concept. That's very powerful because it's very general. But will it be the case that that outperforms taking the small data set and fine-tuning, right? It's a good question. I think there are complementarities, and you could imagine that models not too far away in the future, given the context, might decide to execute a small fine-tuning step themselves, right? That's kind of this agentic behavior of these models. We certainly have models using tools for enhancing their answers. So maybe there's a hybrid. It's a cool question. I hope that in the limit you don't need to do that, but if in the interim it might be quite a cool area to research. But yeah, that's a very, presses my mind a lot, this kind of question. So happy to discuss more offline. Cool. Okay, I think that let's go eat something, I guess. Thank you so much. Oh, okay, last, okay, sorry.
The last one.
It's fine. I think we took his mic away, so let's yeah.
Thank you for your presentation. I have a question about what do you think about electrical issues for the next generation of generative AI models? Thank you.
I mean, I think most of the questions cover a few. I mean, that's a very broad question. Yeah, I mean, I hope at least a glimpse of the ethical issues and some of the things we have at our disposal have been answered. Maybe if you want to zoom out, what's important here is that we get data to understand what are the unknown issues. I think that's the most tricky bit, right? Like you might think, you're building products, you put it in the hands of billions of users, and then there's a surprise. So you want to do that carefully so that you don't run ahead and then make a mistake that would go too far. I don't think we're in that singularity area yet. So luckily we can do some incremental steps. And so what you're doing is that putting something out, analyzing. We have, of course, amazing teams looking at safety aspects. Even one of the largest teams in Gemini itself is actually thinking about that. There's Anka, who is at Berkeley, who's amazing, actually. She's very good. So we're thinking about that. We're trying to iterate a little bit. If you don't iterate and you black box the model, and then you put it out after many years, I think that would not be pleasant in terms of the surprises you would get. So I think incremental and careful steps, not always perfect, is the more general answer I can give of what we're currently thinking or doing actively. Good. Thanks.
I join the audience, thanking you very much for this very inspiring talk. And with this, we are about to close the session. I guess many of you have a very full agenda always, and instead, and you have been here. So this is very valuable, and we really thank you for your support to the ELLIS Unit Barcelona, which I hope will continue in the future. And well, this is the end of the formal inauguration of the unit, but let's go outside, celebrate with a toast, and enjoy. Thank you very much.